All right, today we're going to do completing the square. It's another way to solve quadratic equations. Okay, so this is the one that you're going to use whenever you do not have a quadratic equation that can be factored perfectly. Okay, so far we've learned how to solve quadratic equations by finding the square roots and by factoring and graphing them. So today we're going to talk about the cases where neither of these work. So we can physically force a change on the equation to make it a perfect square trinomial, and this process is called completing the square. So basically, all you have to do is take half of your b term and square it. Okay. So in this, remember, trinomial, you have x squared plus bx plus c, right? So all we do is take half of our middle term and square it, and that becomes our c term. So for number one, it says find the value of c such that each expression is a perfect square trinomial. So here, what is half of negative 16? It's negative 8, right? And then what's negative 8 squared? 64. So that's all it is. C is 64. And so what you did here, when you put 64 in place of c, you now have a perfect square trinomial. So you know that that perfect square trinomial is going to be x squared minus 16x plus 64, and we know that we can factor that to be x minus 8 times x minus 8, or x minus 8 squared, right? Okay, so that's all we're doing. Okay, I want you to pause the video now and try to do numbers 2 and 3 on your own in your packet. Okay, hopefully you work the problems out, and let's see if you got the right answer. Okay, so for number 2, when you take half of 20 is 10, right? And what's 10 squared? It's 100. Okay, so the value of c to make this a perfect square trinomial will be 100. Okay, and so to check yourself, x squared plus 20x equals 100. And also that factors to be x plus 10 times x plus 10, or x plus 10 squared. Okay, so number 3, you had to do the same thing, and here you take half of your middle term. So half of negative 5 is negative 2.5, right? Okay, so negative 2.5 squared is going to be 6.25. All right, so now when we get our perfect square trinomial, it's going to be x squared minus 5x equals 625, which factors to be x minus 2.5 times x minus 2.5. Have you noticed the trend that whatever your the term in your factoring is just what's inside of the parentheses here? Negative 5 halves is negative 2.5, right? 20 divided by 2 is positive 10. And then here, negative 16 divided by 2 is negative 8. So it works out pretty easily like that. Okay, so you may be asking yourself, I haven't solved a quadratic equation using this yet, so let's try solving one. Okay, so when you solve a quadratic equation by completing the square, you do not want to set it equal to 0 at the beginning, because that's just going to cause a lot of adding and subtracting that's not necessary. So if you were to work this out and not knowing that it didn't factor, if you brought negative 16 over to this side and set this equal to 0, you would see that would be unfactorable. So what you do is that we complete the square on this side of our equation and set it equal to here. So when we do that, I have to take half of 6 and add that here. So what's half of 6? It's 3, right? And so 3 squared is 9. So if I add 9 to this side of my equation, to the left side of my equation, I also have to add it to the right side of my equation. Remember, and the reason that I have to do that is because what I do to one side, I have to do to the other side in order to keep it balanced and equal. Okay, so now I have a perfect square trinomial. It's x plus 3 squared equals 225. So in order to solve for this, I have to take the square root of each side. Okay, so if I take the square root of this side, I have to take the square root of this side. So remember, when you voluntarily take the square root of something, that becomes plus or minus, right? Right? In order to solve for a problem. So now I have x plus 3 is equal to plus or minus 15. Right? So when I solve for this, I have x plus 3. Hang on a second. I have two equations. So I have x plus 3 equals 15, or x plus 3 equals negative 15. So when I solve on the left side of my equation, I have, if I subtract 3 from each side, I have x is equal to 12, or, let me see, where's this? or x is equal to, so negative 15 minus 3 is going to be negative 18. Okay, and this is my solution. So that's all it is. You solved an equation using completing the square. I want you to try to do number 5 on your own. Okay, pause the video and try to work it on your own. To solve this one, I take half of my middle term, so negative 6, half of negative 6 is negative 3, and negative 3 squared is a positive 9. So what I'm going to do is add 9 to each side of my equation. Okay, so now what I have left here is the perfect square is going to be t minus 3 squared, right? And that's going to be equal to 256, because 247 plus 9 is 256. So now I take the square root of each side. Okay, to solve for t. And so when I voluntarily take the square root of something, I have to make sure it's plus or minus. And then once I do that, the square root of t minus 3 squared is t minus 3. And that's going to be equal to plus or minus. Let me see if I can do this. Okay, so that's going to be equal to plus or minus. So square root of 256 is, let's see, what's going on? Sorry, guys. Okay, so the square root of 256 is 16. Okay, so now to solve for t, all I do is, so forgot to put the plus or minus here. Okay. So now all I have is t minus 3 equals 16, or t minus 3 equals negative 16. Okay, when you solve for t, you get t is equal to 13, or t is equal to negative 16 plus 3 is going to be negative 13. Sorry guys, 19. 16 plus 3 is 19. Okay, so bold that. Here we go. And that is our final answer. Okay, so hopefully you got those. Alright, so here is to solve each equation by completing the square, if necessary, round to the nearest hundredth. Okay, so how do you think we're going to do these? Okay, we're going to solve these the exact same way as we did numbers 4 and 5. So since this is not a perfect square trinomial on the left side of the equation, I need to move 16 to the right side of my equation. Okay, so I have x squared minus 14x equals, if I moved 16 to the other side, I have negative 16. Okay, so now I need to make the left side of my equation a perfect square trinomial. In order to do that, I have to complete the square. Okay, so what am I going to add here? I'm also going to have to add to the other side of the equation. I'm just putting it in parentheses so you see that we're adding the same thing to both sides. So half of negative 14 is negative 7, and what's negative 7 squared? It's positive 49, right? Okay, so if I add 49 to each side of my equation, now I have a perfect square trinomial. So this is going to be x minus 7 squared equals, what's negative 16 plus 49? You got it? It's 33, right? Okay, so now I take the square root of each side. Okay, remember I voluntarily took the square root of this side, so I have to make sure it's plus or minus. Okay, so now I have x minus 7 is equal to plus or minus the square root of 33. So we have x minus 7 equals negative square root of 33, or x minus 7 equals positive square root of 33. I really need to figure out the shortcut to putting a square root symbol in. Okay. Do this. Okay, so since square root of 33 is not a perfect square, all I have to do is solve for x on each side. So when I add 7 to this side of the equation, I end up getting that x is equal to positive 7 minus the square root of 33. Or x is equal to 7 plus square root 33. And I can't simplify that any further because square root of 33 is not a perfect square. Sorry guys, that should be an equal symbol, not that. Okay. Okay, and that is my final answer. Okay, so try to do number 7 on your own. Pause the video, and then when you finish, check your answer. So we know this is not a perfect square trinomial, so I need to bring 15 on the other side of my equation, and I get x squared plus 9x equals negative 15. Okay, in order to complete the square on this side of my equation, I take half of my b term and square it, so half of 9 is just 9 halves, right? Okay, so you can leave it as a fraction. It'll make your life easier actually in the end instead of turning it to a decimal, but you have your calculator so you can do that as well. Okay, so what we have here is 9 halves squared, and then we had to add 9 halves squared to the other side of the equation. So if you leave it alone, you can just put x plus 9 halves squared is your perfect square of trinomial equals negative 15 plus 81 over 4, because 9 halves squared is 81 over 4, correct? Okay, so we take the square root of each side, and so negative 15 plus 81/4 is 5.25. Okay, so when you take the square root of each side, you end up getting that x plus 9 halves equals the square root of 5.25, and x plus 9 halves equals the negative square root of 5.25. Okay, when you solve for x, you get this. You have to subtract 4.5 on each side of the equation, and you end up getting that x is equal to negative 2.21, or x is equal to negative 6.79. Do not be afraid if your answer comes out to be a decimal. Okay, so you can plug these numbers into your original equation in your calculator and make sure it comes out to equal 0. Okay, and that's the way you can check yourself. Alright, so make sure tonight that you do your homework for completing the square, and I will see you guys all tomorrow, and we'll talk about the quadratic formula and the discriminant.